In this video, we're going to talk about AWS Step Functions. When you have many services working together, it's not always obvious how to keep track of the order, the logic, or what to do when something fails. You need an automation workflow to fully manage these processes and logics for you. That's exactly where step functions come in. Step functions are designed to tie together the different parts of the application into one smooth workflow. Instead of you having to write piles of code to decide what runs next, how data moves between steps, or what to do if something fails, step functions handle all of that for you. Think of it as the built-in traffic controller for your application, making sure every step happens in the right order, errors are caught, and information flows exactly where it needs to go. So how does it actually make your life easier? Let's break it down step by step. Let's begin with the foundation, defining a workflow. Before anything else, you need a way to clearly lay out the steps of your application. Think of step functions as a way to draw your application as a flowchart. Each box in the chart represents a task, maybe a Lambda function, maybe something else, and the arrows show what happens next. The nice part is you don't need to imagine it. You can literally see it in the AWS console. So instead of guessing whether your services are talking to each other correctly, you get a clear visual map of every interaction step by step. That makes your system easier to design and much simpler to debug later. Now that we know how these steps are organized, the next question is, how do they actually talk to each other? This is where passing data between steps comes in. One of the really handy things is how step functions handle these data. The output of one step can automatically become the input for the next. So you don't have to write extra glue code just to pass information around. For example, if one step produces a file name, the next step can take that file name and process it. The other thing that step functions handle for you right out of the box is error handling and recovery. Without the step functions, you'd have to write retry logic, error messages, and backups yourself. But with step functions, you can model that right into the workflow. So if a task fails, you can tell it to retry a few times, switch to a backup plan, or even send a notification. That means instead of your application crashing or leaving you guessing, step functions give you built-in safety nets that keep your workflow reliable. The other built-in feature is step functions let you run tasks in parallel, like resizing an image, scanning it for text, and storing it in a database, all happening at once. Or you can build a branching workflow that if a test succeeds, maybe you notify one team, but if fails, you alert another. This flexibility, being able to run steps in parallel or branch out based on results, is what makes step functions so adaptable to real-world applications. Finally, let's talk about something that every developer cares about: knowing what actually happened. Did the step succeed? Did it fail? Did it retry? Step functions give you built-in tracking. Each step is logged, and you can check whether it succeeded, failed, or retried. That visibility means you always know where things went wrong and can trace the entire process without guesswork. Alright, so the key takeaway to remember is with step functions, you can simplify even the messiest process into a series of steps, whether straight line, parallel, or branching, that stay visual, reliable, and easier to maintain. Thank you so much for watching. Please make sure you're subscribed to our YouTube channel, and I'll see you in the next video.